Hello, everyone. Today we have an special webinar. This today, in fact, it's not gonna be me, the one who's gonna be speaking. It's gonna be Omar Suarez from the company Sunthalpy. He's our special guest today. This new technology we have already tested with our heat pumps is fully compatible with all the Ecoforest range. So the idea is introducing you how this new solution can help you in your projects. There are some additional features that Omar is going to explain you today that you are going to find very useful. And he is also explaining you how also it's operating with our heat pump. So Omar, thanks for joining us today. Thanks for your time. And now it's your time to speak about the Sunthalpy and your technology.
Thank you, Adrian. Well, as Adrian introduced, my name is Omar Suarez, founder of Sunthalpy. These solutions that we are going to present you today, just to make a further introduction to Adrian's, are available with Ecoforest, or they will be available through Ecoforest all throughout Europe. So if at the end of this presentation you are interested, you just contact Ecoforest because they are the channel. And I call this presentation how to convert any building into net zero. And when I say any building, I'm talking about new buildings, but also about old buildings with little insulation as it used to be in the past. And basically the solution, just to make a brief introduction, what we do is we have compacted a much more efficient system than underfloor heating to provide low temperature heating and cooling. And we do it with two devices. You can see here this picture you have on the top on the ceiling. You have what we call the Sunthalpanel, which is an evolution of a radiant system compacted because it, as we will show, is very efficient. And hidden on the wall, just beneath the window, there's also another system we call Sunthalpy that basically works the same. It's just different installation. And well, let's go first to introduce you Sunthalpy. Sunthalpy is an engineering company founded in 2017. In 2019, we created the first 100% solar off-grid building in Atlantic climate. It has been like that for the last 3 years. Then in 2020, Iberico Group joined us. Is one of the biggest European special aluminum products manufacturer. And with them, we compacted our solutions into these retail solutions that we are going to introduce you today, that we are using to transform, as I said before, any old building into net zero. So, well, basically, let's move on. Before I was showing you Sunthalpanel and Sunthalpy in this introductory, in this index, we start introducing you. You can see the real image and the thermal image. You can see how they are hidden or there, but you can see how active they are. Well, let's go through. Well, basically, we have, in order to make 100% solar or net zero buildings, 38% of CO2 in Europe comes from construction. From that 38%, 28 basically is energy for maintenance of the buildings, and most of it is basically for heating, domestic hot water, and cooling of buildings. Also part of the home appliances. Although everybody believes that the demand is electric, dishwasher, washing machine, freezer. Actually, they are thermal machines that they are not very well operated. And there's probably in the future an opportunity. But when we look at the existing buildings, Europe is focusing in the transformation and the replacing boilers to heat pumps, and that's right. That's a great thing to do, but we want to go a bit farther. The big problem, indeed, are what we call radiators, traditional radiators that basically it's a cheat because they don't radiate. Basically, they are designed in such a way that what they do is to heat up air, and in order to heat up air, they need very hot water temperatures, which basically that situation is forcing us to use either boilers as a first choice, being pollutant and very high cost in fuel. Just have to remember that at least 30% of the energy from the combustion goes to the environment straightforward through the chimney. It doesn't matter, as long as you have a high temperature emitter, energy is lost. And then comes the heat pumps. But here I'm using example of performances of a very good bring water variable speed heat pump from Ecoforest, and you can see that. Yes, of course they can operate at very high temperatures, but the graphs on the top, which are with a temperature differential which is low, they have twice the performance than when we are forced to work with water temperatures on the production above 50 Celsius, where the COP really gets reduced. And this is important because if we want to be not just to be forced by law to get the replacement of the boilers with the heat pump, we have to try to be as competitive as possible to get the highest possible COP in order to reduce the real cost of the thermal energy we are supplying, in order to get a return of investment as short as possible. This graph shows you on the y-axis is the COP, starts in 2, and on the x-axis we have the differential of temperature between the water source and the production source. And of course, actually this case is an air source, water heat pump operating. And whenever we operate with a low temperature differential, the performances just rocket. And also it's important, you can see different colors that they refer to the different speeds of the compressor. When these machines and Ecoforest really do it very well, when they operate in the medium range revolutions, the performance is even better. And that's what we have to do. We have to operate our projects with the lower potential temperature that our customer can afford. And we're always trying to operate the heat pump with a medium revolution range. So as well, these but not well called radiators, we call it natural convectors without fan. They are not compatible as well with solar energy. They provide bad comfort because, as we said, they heat up the air. And then you have this situation where your head is hot and your feet are cold, which is not a good comfort. And as well, because we have this movement of air, we are blowing the dust, which actually is something that affects the health. And when you remove radiators and you truly implement radiating plates and you get rid of convection, the dust disappears. It goes, you remove the energy in the air, and the dust goes to the floor, and the vacuum cleaner removes it all. And it's something that we have learned together with our customers with the transformation of the old buildings throughout this last couple of years. And radiators do not cool. You will always need additional air conditioning. And with our radiating systems, you can provide both systems with a superb performance and comfort. And apart from that, they are dirty, they are ugly. I really don't understand why we still have radiators. Well, what are the alternatives? Of course, we have underfloor heating, and that's a great solution. And it has been every project that has been the underfloor heating has been accomplished perfectly. We basically get a very similar result, mainly concerning heating. But underfloor heating, the problem we have is, we have to replace, we have to refurbish all the buildings in Europe. And implement, once you have someone living there, it's very complex, it's very costly to introduce a radiant system on the floor. And as well, because most of the times they are not executed as they should, they are not suitable for an active cooling. Because basically the mortars or concretes that you use for the radiating block, the radiating slab, they have low thermal conductivity, and they don't, as we will see later on, to provide cooling, you will always have the dew point as a limitation to power the system. So, every day they demand a lot of labor on site, which is a limitation nowadays. Then you have plaster radiant plates that simply, sorry, they don't work. The plaster is low thermal conductivity, and you need a huge temperature and a huge surface, and they are out of the market actually today. And then we have metallic radiant plates, but they are costly and difficult to integrate from the architectural point of view, and fan coils that, well, they are more efficient than radiators because they require less temperature, but they need a really high temperature for what we want in order to get the best performance of our heat pump. And definitely they provide a bad comfort, hitting the head, getting feet cold, they make noise, and they move dust. So once we have this introduction, let's see the technology and the solutions that we present. And just as an introduction, just to have a look at this project where we have a renovation of an old flat. You can see a television and a wall on the sides, and on the thermal image, you can see how we are heating at relatively low temperature with a uniform system, that special room. So let's go to the cake. On the right, I present you an image of a traditional underfloor heating system, and there you can see, well, the usual image where you can see the tubing with the projection of the tubes are hotter, but this actually, even though you see that temperature increases, there's always a differential of temperature between the water of at least 3-4 Celsius between the water you are pumping and the actual temperature you manage to have on the radiating and convecting surface, either is wood, tiles, whatever finishing that you have. And there's a loss of performance, but the huge loss of performance is because you see between tubes, that intermediate surface is working at much lower temperature because as we said before, the concretes, the mortars that we use for underfloor heating, they are low conductivity. And so in the end, yeah, we can have a huge surface, but only some part of it is working. On the left, we have one of our systems, of our plates. You can see we have a uniform temperature. You cannot see where the tubing is because we basically is high conductivity. All the materials we deploy for our plates are very high conductivity, so we have a perfect diffusion, and the average temperature of the plate is, our circuits. We used to work with a temperature differential between the input and the output between 2-3 Celsius, and we always have the average temperature of our plate is between both. So we are making a perfect thermal transfer. Basically, while a traditional radiant floor, you have a heat transfer coefficient of 4, we have a higher coefficient of 13. We are more than 3 times more efficient than a traditional radiant floor for heating, and way more efficient for cooling, as we will see later on. Basically, we only need a 30% of the surface to make something equivalent. And this is possible because basically we have so far all the heat exchangers, radiators, they follow the technique of the traditional tube fin heat exchanger. We have basically created a solid, a 3D heat exchanger that overcomes the limitations of these tube fin heat exchangers and radiators. And we do it in a plate, which is a honeycomb. I introduce it to you is this element. I don't know if you can see me there. This is a aluminum honeycomb, very, very light. You can see it is composed of two layers of aluminum and the honeycomb, which is inside, which is very thin. This is produced by our partner, Iberico, the multinational I mentioned at the beginning. And what we do is we have a tube, a very thin tube, which is a tube of very well-known mark of radiant systems, that we glue this tubing with one of our patents is we created a mortar, which we can use in the same way you can use a mortar, but this mortar is high thermal conductivity. From the thermal point of view, it's more like a metal than a traditional mortar element. So this, basically we have created these 15 millimeters plates that are lighter. They are cheap in the sense compared to traditional radiators, and they are very resilient. We are using it even for solar applications. They are impossible to break. And because we can display big surfaces with high efficiency, then we get great performances. And this technology is protected with actually with one European patent and another one which is Spanish and is going to become European in the following months. So once we implement these low temperature emitters for heating and cooling, basically we are overcoming the most important energy barriers to make any building efficient. Because when we compare a heat pump working with radiators, we are increasing, when we introduce our systems, we are increasing the heat pump performance by 250%. And something that is, well, we were about to do it, but we are because our systems, they radiate mainly. They do not produce much convection. We don't heat up the air. We radiate. Then what we managed to do, as we will explain, we increase the activation of the thermal mass of the building, of the structure, of the furniture. We are managing to increase their temperature without heating up the air above the temperature we managed to introduce on those elements. That is allowing us to convert any building into a thermal battery that we will get, as we will explain, a great benefit with that. And also, this technology is allowing us to transform any PV panel into a 100% efficient one and resilient. And resilient, basically, we make some kind of PVT panels. We don't like that determination, but just for you to understand it. And the problem was not about to make more efficient solar panels. The problem was to solve was to place a tandem, a team of the photovoltaic and a thermal working together in the right point where both perform the most, as we will see. So, well, we come back to the initial graph we saw before, simplifying this case. When we talk about how to get the most of our heat pump, I want to introduce. We love to work with Ecoforest water or rainwater heat pumps. Even when we use air source using an AU and outdoor fan coil, it provides the fact that the evaporator is working against water, always produce a surplus, a benefit. And as we said, if you work with a radiator, then the temperature differential is high. You're going to get a low performance. If you're working with an air source, depending whether it's a traditional air source heat pump or a water with a fan coil, you will get performances clearly about 5, 6. And if you manage to have also higher quality, higher enthalpy sources as solar, as we will see, then the performance just can rocket. And well, let's go. So here on the right, sorry, we see a diagram that shows we have a radiator, a traditional water radiator that is heating up the air. And in this room, yeah, we have hot air on the top, on the ceiling, and cold air on the bottom. That provides very poor comfort. As we said, it moves the dust, as we said, but also that air doesn't have mass. Air is a bad heat transmitter. And then the heat transfer rate of air against a solid is very poor. So in order to heat up the mass, the structure of the building, we have to keep working continuously and at high temperatures inefficiently to be able to heat up that mass. However, if we work at low temperature with a high surface element radiating, from this element, we are being able to heat up our structures, the furniture, and we are multiplying by 4 the activation of the thermal mass of the building. And this is very important because it gives us, as I said before, the opportunity to actually convert the building into a thermal battery. So when, for example, it allows us, once you have a battery, it allows us to charge that battery. For example, during daylight, when for example in your project you have a photovoltaic system producing primary electricity and which is free, then you can take that electricity and you can multiply it by 5, by 6, by 7, depending on the COP of your heat pump, and inject it to the structure of the building during daylight. Actually, in that moment, during the daylight, the normal thing is if you have an air source system or a solar heat source, your source temperature will be much higher. So you will have also a better performance, having free electricity, free primary energy, and a higher quality secondary energy in order to store until the night when everybody comes back home, and then you may have a peak demand of electricity for the home appliances, and then you can switch off your heating system or your cooling system because you have already stored that homogeneous temperature all around inside of the mass of the building. It's a great business opportunity, and actually we are right now in a development project with a utility that are starting to see that the future is the management of these opportunities. You know, one of the big problems is what do you do when you have big storms and the windmills? They produce a lot of electricity, and there probably in that moment there's no demand. These systems can allow us to, or are the key to pair the grid demand to the renewable generation, and which is one of the biggest problems. I'm aware that in countries like Holland and nearby, they are having big problems with the saturation of the grid. This is a solution. Definitely is a solution to solve this situation. So let's see. Specifically, we have been talking about theory. Let's go to see the products. On the left, we see the Sunthal dress. The Sunthal dress is displayed, and it is installed like a plastic board, and is perfect for new buildings of big retrofit systems. And on the right, well, you can see here on this video, you cannot see the plates. You can put tiles, you can put paper, you can put glass or mirrors. And then on the right, we see the Sunthalpanel, which is basically a modular, an improved modular, very easy to install radiant system that is going to replace or works like underfloor heating, but we put it on walls or ceilings, but is installed very easily like a traditional water radiator. And probably now that you are seeing that on the ceiling, you will say, well, hey guy, you're going to provide heating from the head. Remember that we are working at temperatures at very low temperature. We have customers that, you know, they have these radiators on the head of their beds. They are sleeping. Their head is only 3 centimeters away from this radiator, but when you touch it, it will be 26, maximum 28 Celsius. So it does not radiate, or it radiates, but you don't feel it because your head is 36 Celsius. It's much higher temperature than the temperature of the meeting surface. So you just feel comfort and uniformity of temperature. So basically, these retail products are the key to sustainable living. So far, we have been told that sustainable living is just losing money because energy will be more expensive, losing comfort because you will have to be colder in winter or hotter in summer. But no, it doesn't have to be like that. The thing is, we can provide a better life for our customers because we increase the value of their homes above investment. We are, for example, one of the cases that we are going to see right now, we have a customer in a detached home that they were spending nearly 4,000 euros a year in energy. And with the introduction of these low enthalpy emitters, Ecoforest water variable speed heat pump, and a very small photovoltaic system of 6 kilowatts peak, they reduce those 4,000 to less than 300, and being positive in the balance of energy in the year. And that's because we are making them to save up to 95% in energy. And apart from that, they enjoy a better comfort, health, and energy independence. And well, now I'm going to put you a very short video of 1 minute and a half where our customers can tell that in their own words.
The house is at a temperature of 22 degrees, with all spaces being at the same temperature. This is an achievement that was previously unattainable. In terms of energy consumption, our monthly usage is now equivalent to what we used to consume in just 4 days.
Just to mention that, for example, this surface is what we call a Sunthal dress. We glue kind of a paper or stone mineral element finishing.
Last year, this significant reduction in energy expenditure amounting to 86% in the month of January, has had a tremendous impact.
I really would like to be able to show it, but in a video, it is impossible to explain what comfort is. But that comfort that you achieve in your home, a homogeneous temperature, elimination of humidity, the fact that you do not have temperature.
Currently, the house is at a temperature energy has had a.
But that comfort, that temperature, humidity, the fact that you do.
Over here, just for you to know that this paper of trees, fancy thing, is a thermal emitter, and that's why I stopped this.
Have temperature differences in the rooms, or depending on the day, you don't care if it's cold or hot. You always.
And in here, the ceiling, this area where you see the LED, also this small wall, and also here where you have the kitchen, this ceiling, you don't see anything at all. We have a perfect integration. This is the Sunthalpy dress.
Keep it with a really low energy consumption, and then on an aesthetic level, well, you can see it at this moment. It is truly spectacular. So I cannot find any reason why I would not recommend Sunthalpy to any person who asks me.
If in our case, it is €0, the pool, the 2 cars, all the appliances, and what we use, and the heating at 23 degrees Celsius, which is the temperature maintained in the house. This mirror is, again, a Sunthalpy dress. This guy that is talking right now, they also have another 100% solar house. This one is not off-grid because, well, they are normal people and they have 2 electric cars and they want to charge their car at night when they arrive home.
Because it's an environmentally sustainable solution. I believe the decarbonization of the planet is something we all have to participate in, each of us, to the best of our abilities.
Okay. So, well, we are all, sorry, we have something new. So, so far we have been seeing what we can do inside of the buildings. And as I said before, we love to work with water or bring water heat pumps, using AUs, a fan coil, exterior fan coil to provide us the heat source. But we also like these machines because we can use them to have another source. I'm going to go forward just first to show you the picture. This is a normal photovoltaic. You can see these panels. Some of them we implement a system like Sunthalpanel or Sunthalpy dress, just glue beneath the solar panel. It's a water cooling system that is going to allow us to cool down the photovoltaic cell, because the photovoltaic cell is supposed to have a performance above 20%. But if you look at the technical data set, you will see they have you a remark. Yes, it's a 20% as long as you have 1,000 watts per square meter of radiation, basically full sun, and the temperature of the cell is only 25 Celsius. That situation is impossible unless you cool down the cell in an active way, as we are doing. What happens when you have that situation, that temperature performance goes down to 12%, usually. If we cool down the way we do it, we manage, even with full sun, to have the 20% performance. And basically the cooling system that we saw or we will see in the next picture, it works like a traditional solar collector. What we do is to introduce water in the solar panel at the same temperature of the environment. Let's say we have 10 Celsius. Then we introduce water at 10 Celsius that comes from the heat pump in the primary. And so this subtraction is, the result is 0. So we are here. So the collecting performance of our solar collector is perfect. It's 70, it's 80%. That in addition to the 20 of the photovoltaic, we basically absorb in either in electricity or thermal, a perfect panel. Sorry, I have a problem with the. Okay. I understand that you're seeing the presentation. Am I right?
Yeah, Omar. There is
Okay.
no issue. Okay, no, we can.
Okay,
Can go.
let's go forward with the calculation. How do we calculate the surface that we have to put on a specific room? I told you before, we need a 30% of the surface of a radiant floor to be equivalent. So basically, if you just make a 30% of the building, you would operate this system in the same conditions that you would operate a traditional radiant and underfloor heating for heating, and it will be much better for cooling. But if you want to make a good calculation, and for example, instead of just being the same performance of a traditional radiant floor system, you want to be even better and work with lower temperatures, you have to make the following calculation. Let's assume that we are studying a case of a room with 11 square meters, and we have already obtained the heat load, the maximum heat load that we can have, and we have determined that is nearly 400 watts, 495 watts, and well, we define as an objective room temperature 21 Celsius on the room. So we only have to make the subtraction of the 30, and we expect to have in those conditions where the heat load is maximum, we don't want to work above 33 Celsius. Ecoforest machines work with a huge performance at those temperatures. And then what you have to do is to take this 33 Celsius minus 21 of the objective temperature. We have 12 Celsius differential. And then the only thing we have to do is to divide the power, the heat load between the 12 Celsius that we just mentioned and the 13 watts square meter Celsius that we defined before as our transfer rate. Then what we get is 3.2 square meters. Okay, so basically we have three sizes for Sunthalpanel. The biggest one is already 3 meters. In this case, there's no problem. We would go for an XL, which would allow us, we would guarantee that it will not operate above 33 Celsius to provide the heating. With the cooling, the ratio of the cooling is the same, is 13 watts. The only thing is you will not be able to work below dew point. That's your limitation. You won't have the possibility to work with 12 Celsius. Usually you can work with a temperature differential of 5, 6, 7, 8 Celsius maximum to work on cooling, but it's providing a superb cooling. It's like being in a cave. And well, if someone is interested in cooling, we can make further discussion another day. So let's go to see how we install it. The Sunthalpanel. We have this short video where we see the first thing to do is to put the fixing points. There's different ways of fixing depending on the surface, on the ceiling, the type of ceiling that you have. But then once you fix using normal mechanical systems, the XL model is 37 kilograms of weight. So in this case, we need an elevation platform in order to hold it. We get it as close as possible, and then the hydraulic connection is similar to the one you would make with a traditional water radiator, but it works like a true radiant system, even better than underfloor heating. So you make this connection. Let's move it forward. It's taking me longer than expected. You make this connection, you make the other one, and once you make both connections, inlet and outlet, of course, there's an air release valve in the system. The you just proceed for the final assemble. The profiles that we provide, they're a similar system that is used for facades. Okay. And basically, well, once you get it close and you clip it and it's there, it does not move anymore. Okay. So, okay, let's move forward. We provide you these plates so far in pallets, up to 15 units per pallet in the case of the big format. And the other ones we will well, the idea is to supply it for projects so far, but eventually they will come with an individual package, and you will be able to order it independently. Then the situation of the plates, basically you just try. We like to work on the ceilings because there's nothing that can interfere. The customer will not want to put a furniture or a frame, and ideally, as I said, them on the ceilings or on the walls. If you find the case, you just have to find a place where you can that spot can have a vision to the rest of the room, because once, even as long as you don't put it behind something, a door or a furniture, it works because it spreads the radiation, and even though if you are like in a side, that radiation will spread all over using the other elements that you have. And as in the video we saw, we have here another example of installation. On the left, we can see how, well, the idea of this project was to replace these traditional radiators that we have here. And on the left, beneath the window, and then we have here the fixing points. This installer, what they do is they put already the piping at the same time that just after the fixing points, even before they remove the radiator, and they use the existing piping of the house, and eventually in this case, well, they put a casing that I really don't like. We are really working right now for an integration of those pipes, because sometimes when you go to the ceiling, you will have to hide it or just groove the wall. But the idea is we are going to start supplying you aesthetic covers that they look like a decoration system, so that we reduce the amount of installation and make something clean. And in this case, I just put you, if you have a customer that they have a lamp, well, our plates can be drilled. You can make holes as long as you don't make a hole where we have the tube. And this is an example that, well, it can get something fancy. And in here we have another example. When the radiators are placed far away from a window, then you will be able to make a direct replacement of a traditional radiator with the Sunthalpanel. It's very easy usually in bathrooms where they are usually placed in walls where you don't have something that interferes, and it really looks pretty well. And also the possibility, I really don't like it, but some of our customers are demanding to our installers to put some LED on it to make these effects. And this last slide is just for you to see, and that also we have sample dress that you could also get through Ecoforest with a special request if you wish to. And this solution is cheaper and is adequate when you are making a full renovation or a new building, where once you put, when you have already a plaster ceiling, then right after you put all the metal installation, all the framing, you first install in a similar way that you install with the screws. In the same way you screw the plasterboard plates, you fix our plates, you connect the hydraulics, you test the hydraulics, and then you put the rest of the plates, just leaving 3 millimeters clearance for the movement of our plate. And then you just plaster it and paint it and finish whatever you want. And well, basically, this is what I intended to see today. I don't know if you have any question. I guess you will have doubts. Please go forward.
Omar, there has been some questions during your exposition. Congrats for that as well. So basically, I'm going to read some of them, okay?
Okay.
So, for example, this is a question for Omar around the low enthalpy breakthrough. If we use a radiator at lower temperatures and bigger surface, wouldn't it be similar to this solution? It's asking our guest ready.
Yeah, definitely. If you're able to provide the required heating in order to get a very good performance of the heat pump, you need to work with operating temperature of the water below 35 Celsius. If you are operating higher, that's no low enthalpy. The performance of the heat pump will fall. If you have another radiator that works radiating, not convecting, with water at lower temperature than 35 Celsius or 30, then you will be able to get very good performance of the heat pump. And ideally, if it radiates, you will also activate the mass. Actually, we are working in an evolution of our technology to make a direct replacement of the traditional small radiators with another element similar to ours, but compacted, smaller, that has some increasing the convection element. We will lose part of the activation of the mass. We will lose part of the comfort of not moving the air, but we will be able to work at low temperature, keeping the good performance of the heat pump, which I agree is the essential thing. So if you find a system that works at low temperatures, of course, go forward.
Second question, how would we cite this for buildings? I have a project at the moment that may be suitable to this technology, but it is a 200 years old. They are doing geothermal on this building, Christy mentioned.
Yeah, well, so, but basically, we have to determine the loads. We have to see if you're going to make an extra insulation of the building. And once you determine the load, the heating load that you're going to have, we have to define what efficiency we want. As I think that this, probably he made this question before we explain how we made the calculation. Of course, if you want, ideally, if you have that case, please contact Adrian, and we can study specifically that case for you in order to determine. Basically, what I will ask you is, how much efficient do you want to be? Because we can make it 100%. We can make it net zero. Yes, we can make it net zero. And always, in order to make something net zero, you need to have a source of renewable electricity. You will need a photovoltaic. Okay, but what we managed to do is, when we get rid of the boiler, you are already saving the 30% of losses that you are losing through the chimney. And then you have the 70%. And if we want to have a consistent COP of 6, we determine then, in order to have 70 divided by 6, you will get more than 80% reduction in primary energy for that heating. And so you get such a big reduction in your electricity demand that even with a small photovoltaic system, you would be able to be net zero if that's the objective. But the objective has to be defined by the owner of the building. If you give us that, we can make that simulation for you and evaluate the solution in this case.
Okay, next questions. There are two questions from Andris. First, one is related to calculation equation. Does it take into account house heat loss in winter? Doesn't it need to
Repeat
get
again,
some?
please. Can you
Does
repeat
it
again?
take into account the heat loss in winter?
Well, that's what I meant. In here we are assuming that we know in this heat loss in winter actually is maximum heat loss for that specific room. Okay. Well, it can be any number. You know. Sorry again. You know what happened here. Basically, yeah, we have in account both heat loss in winter, and if we are in South Europe, we have to take also in account actually in Greece what will define the surface that we have to implement. It will be much more the summer rather than the winter.
Okay. So he said that now it's okay. He has another question that it was on the ceilings heat distribution wouldn't be the best, no? Okay, I will go to the next question. Okay. I have here because there are a bunch of them.
If he was saying that, if he was saying, I think I explained it before, because everybody asks that. How in the hell you are supplying heat from the head? But you know, of course, people say heat goes up and cool goes down. No, heat doesn't go up or down. Heat, when its radiation, goes everywhere. When it goes up is hot air. Hot air weighs less and goes up. But we don't heat up air. We heat up mass with radiation. And is the mass, the hot mass, the one that heats up the air at the same time. We always have same temperature in the furniture and on the walls and the ceilings and in the air. It's not like a radiator that heats up the air. You try because you never get it. Try to heat up the walls. It's different, but it's important. And you know, this concept, everybody asks us about it. It's normal.
Okay, so more questions. Paul Cushing has 3 questions. Can the system be modeled effectively in a SAP database? I don't know if you are familiar with a SAP database, Omar.
No. Well, we haven't done it. We have to look at it.
Okay. Yeah, for heat pump it's pretty common, but I don't know if it's for a new technology, it's something compatible, you know. I guess that there are gonna be ways to do it. Do you have any schematic of the total system with the PV cooling system?
Yes, of course, we can share it with you. Just give us the email and we can send you the schematic of how we can do it.
I think that this question is yes. Did you say the ceiling panels can be plastered over?
The Sunthalpy dress, yeah, we plaster the joints just to get a continuity between our own plates and also the plaster boards. You plaster the joints and then you just polish it, and paint it, and so you get a fully integrated emitter.
And I think this is the last question. If not, I'm going to copy the chat, and then when we send you the okay. Question regarding controls of Sunthalpanels. It is by a standard water flow control thermostat?
The control, you can implement whatever control you already have a standard in the system. There's something to take in account is just that, normal thermostats, they just measure dry air temperature. When we implement radiating temperature, we are actually changing the usual radiant temperature, which actually is what people feel. People does not feel air temperature. What they feel is the balance of energy of us with the air and with the rest of elements. But basically, yes, answering your question, we use standard thermostats like the ones that Ecoforest is supplying. We use Ecoforest control system. We also have our own control system when we operate our special projects. But the control, you don't have to change anything. You just have to replace your radiant floor or your radiators with our systems, and they will let you be or they will let you implement it in a much easier way, in a quicker way, and be more efficient and provide a better comfort, supplying both better heating and definitely better cooling.
There are more questions on the queue. Okay, so do you have experience solution on exchange of existing radiators and placing at the same place a Sunthalpanel?
Yes.
Because he said that if from your calculations, it should be 3 times the radiator. So that is the
3 times or sometimes 6 times as well. Yes. That's, as I said, is the biggest limitation. Well, we created Sunthalpanel. We first created Sunthalpy. The only thing Sunthalpy implies still some work. And then we decided, once we saw how good the performance of Sunthalpy was, we wanted to move forward to a simple installation that any plumber, any thermal installer could do. Of course, the limitation is if the equivalent Sunthalpanel does not fit, you will have to find either other wall or the ceiling to put our Sunthalpanel, and then use the existing piping. You will have to add existing pipes to take the water inlet and outlet to the panel, and that's where we are working. Of course, you can groove the wall, you machine the wall and plaster them, but that's complex. Our installers, what they are doing is just piping new and covering, making something fancy. Although I cannot show you today, we are working with a decoration company, special plaster profiles company. We are working in a very fancy solution that even yourself or even architects and interior designers can make something really fancy if you have to make a lot of tubing. In bathrooms, as I said, for example, or sunrooms, you can make a direct replacement, and then there's no extra piping. And as I said before, we are working in a compact solution. It won't be as good from the comfort point of view, but it will work at low temperature as well, introducing some air movement. You have mute, Adrian.
Yeah, I'm sorry, because if not, the alert from the computer is. Okay, another question is, what is the maximum temperature that the panels are working up to?
Okay, Sunthalpy. Yeah,
or...
Sunthalpy is limited to maximum 40 Celsius, just to prevent cracking. We have tested extensively up to that temperature, and we don't, there's no point in using higher temperature. Ideally, they have to work always below 35. We have those 5 Celsius of margin. And ideally, you have to make it work below 30 Celsius. In case of Sunthalpanel, there's no limitation. You could introduce water to 60, 70, 80 Celsius. It will withstand without any trouble those temperatures. But it's not the idea to make it work. Of course, you could be used it as a fancy radiator. That's right. But that's not the objective. We want the heat pump to perform the best as possible, and the idea is to make the dimensioning to make it appropriate to work on those low temperature conditions.
Okay, and this is an installation question. Okay, this is basically how are the panels balanced compared to using a lock shield valve on a radiator? Is this not an issue if these connections are no longer accessible? So, for example, we need to reduce flow to panels closest to the heat source, or how this works?
Of course, we have we like to operate with higher water flow than usual. So far in the transformations that we are doing, as long as the problem is when you have an existing hydraulic system where you have all the radiators in series. If you have that situation, we have a limitation. Maximum we can put 2 XL in series. I mean, we always try that all our panels are in parallel, okay? Feeding them independently. As long as you have a half-inch water pipe and all of them are in parallel, there's no problem. The system will work. If in a specific case, because you are using an existing hydraulic system, maximum you can put only 2 in series. Okay, I don't know if I'm answering the question, Adrian. You're mute again.
Sorry. Yeah, I think so. Basically, if not, what I am going to do is as I mentioned, we are going to send to all these people the record. Also, if you share with me the slides as well, so we are going to share with them slides and record, and I will take a copy of the chat, so we can.
The only thing about the presentation is, as you see, they contain videos. I will put a link to the video if possible, if they are on the internet, but well, you will lose part of the videos.
Okay, so more questions that are still coming. For example, in question of cooling, so it's a question that people usually have also with underfloor. How do you manage condensation? If it's necessary as a humidity sensor or so.
Sorry?
If you need something like a humidity system or dew point or something like that, I guess.
Okay, the cooling, as there's interest, I'm going to get deep on it. The cooling, of course, you have the dew point limitation. If you pump, let's say you have a humidity of 70% and the room temperature is 21, you know for certain that if you pump water at 18 Celsius or below 18 Celsius, you will have condensation dew. At this case, our plates, and we know that because we have a customer that installed our plates, but they didn't install Ecoforest heat pump. They did it on their own, and so we didn't have any control about the control of the heat pump. And we told, well, we live in a very, or this project is in a very humid area, and we tell them, okay, limit the pumping temperature in cooling above 18 Celsius. And the guy say, no problem. He told to the installer, and the installer didn't know very well the machine. They fixed minimum temperature 18, but they allow still some working gap. So actually, when they started, straightforward, the heat pump started operating 12 Celsius. The whole wall in a couple of 10 minutes was like full of tears. It was water on the wall. The good thing about these plates is that the water forms on the surface. It doesn't form around the tube as you could suffer in an underfloor heating system. This guy made a mistake. He didn't complain. He was noticed. He realized the mistake. He changed it. The water just evaporated. There was no mark at all. Disappeared. So, well, that situation happens. What do we do to manage this situation? Okay, if we have the possibility, as he mentioned, to have a humidity control, and we try to put humidity controls everywhere, that gives us always the minimum temperature that we can use. Usually, the plate you don't need to put less than 18 Celsius, because if you introduce water at 18 Celsius, the plate, when you get close to it, you already feel the cooling effect. Okay, but let's say that you didn't put as much plates and it's a very hot day and basically more than hot day, you have a lot of sun getting through the window and striking. Then, of course, if you have the humidity control and you are able to, Ecoforest control system allow you to define the pumping temperature limit right above the condensation point, so you can deliver much cooling power. And once we got into this cooling, if we are talking about Rome to the north, there's no problem. Yeah. But if we are talking about Rome to the south, Madrid, Athens, those areas where it's pretty hot in summer, and we have our system is able to cool down without any problem the heat gains that comes through the envelope. And actually also we can remove we are able to remove the heat that comes from the sun. You know, the sun has a lot of power. What happens if we have a lot of sun? Okay, we have been cooling this building throughout the night, and the building, the walls, the floor, everything is around 21, 22 Celsius because the customer defined that. Then the sun comes through the window, and the sun is very powerful. And of course, we could put our plates on the floor we have done it, and it's the best you can do to absorb all that sun radiation. So you don't let the air to heat up. But even though the floor has been cooled down, if the sun strikes, you cannot stop that. What happens? What happens is the air doesn't have mass, as we said, and doesn't have a specific heat. So the air will increase temperature very rapidly, okay, until you reach a certain temperature. The radiation of our plates, as I said before, our plates do not heat, do not cool the air, because air is not affected by radiation because it doesn't have mass. Air is affected by convection. So in that situation I was explaining, the air will heat up until it reaches 24, 25 Celsius, and you have created a temperature differential between the surfaces, and then convection, natural convection between not only our plates, all the surfaces of the room starts cooling down. It's like an anchor. We anchor that temperature. And the feeling is not like the feeling where you are the typical hotel room, you enter, everything is hot, the surface is hot, the air is hot, and you put the air conditioning, and either you are cold or you are hot. In this case, even though the temperature can reach to 25 Celsius, because all the surfaces are cool, the radiation you feel is pleasant, you feel comfort. If you have a customer, or you're in a situation where you want to have full control of the air temperature, of the dry air temperature, you have to add a small fan coil in order to make that tuning. The big advantage is you will not have to cool. If you use that fan coil, you will not have to produce water at 7 Celsius as is normal when you have air conditioning systems. No, you can operate with the same temperature of our plates with a high water temperature, and most importantly, with air flowing similar to the airflow you need for the ventilation. You don't have to provide the cooling. It's just to make the tuning of the air in case the customer demands, I want to be at 20 Celsius. I want to be at 21 Celsius. Here in Europe, I think we don't have that trouble. But if we go to Middle East or to Mexico, countries where from a social point of view, the customers are accustomed to be really cold. They like to be cold. Well, in that case, we have to implement that hybrid solution with using radiating and fan coils.
Okay, so the last questions, what are the KV or KVS factors for the different sizes, okay, XS, S, or XL panels?
Repeat again, please.
Okay, what are the KV or KVS factors for the calculation of the
KV,
panels?
I don't know what the KV is, sorry.
KV. kV.
How do you choose between one or another?
Yeah, exactly.
Well, basically, as we explain in this is the procedure. If in here, if we have a small room, let's say a bathroom, usually you will have to use an XS or an S. Let's imagine that instead of having a 11 square meter room, we have a living room, which is 20 square meters. Usually you will have to use 2 of these or 1 of these and 1 of these, depending on the procedure is to follow this simple calculation, basically. So that's it. And basically you mark your objective. You do the key point is what is the maximum temperature you want to define for heating or cooling. As I said before, for southern countries, the key calculation factor would be the cooling, the cooling load that you want to make with this radiant system.
Okay, so the pressure drop is in bar or kilo or in pascals, pascals?
Kilopascals.
Kilopascals.
Okay. As I said, but just take in account, as long as from the distribution to the panel, you have less than 25 meters, as long as you fit it with half-inch pipe, is more than enough. If you have more distance, go for a 3/4. And of course, this stage, although we have that data on the technical data sheet, please count on us to make the calculation to determine the hydraulic pump that you would need. Just let us know, and we help you with that.
Okay, so I think that this is all. As I told you, there is if there is any further questions, we will send you a copy with the questions and answers. So thank you so much, Omar, for this presentation. Thank you so much for all the attendants for being with us today. So very soon we are going to release the webinar for next month. If you have any question, you have my contact details. And I will submit to Omar. Okay, so thank you so much. Have a nice day to all of you, and thank you, Omar, again.
Thank you all.
Bye.
Thank you for your questions indeed and your interest. Bye.